My name is Sai. I'm a field engineer working here at Solo.io, and I'm based out of Singapore. And thanks so much for coming to the workshop. So before we start the workshop, can I just know if you are any one of you familiar with Service Mesh, Istio, or Envoy Proxy? Cool. So what about any developers, platform engineers, SRE, DevOps? I see. Cool. So mostly from the infrastructure space. Architecture. Yeah. Cool. Thanks. Okay. So we're going to be running solo. We're going to be presenting 2 sessions. One today is eventually the workshop, hands-on workshop, and tomorrow is about talks like delivering business values with Istio. I mean, it's going to be nice that we're going to start with the other one first and then do the hands-on. So now it's the other way around. So, but I'm going to introduce a little bit about why we do Istio first, and then we will do the hands-on. So for the hands-on workshops, if you want to follow along, or you want to do your own time, you can go to this link, and you can have 7 days of access to the lab, and then after that you can take the picture of it, and if you go to this link, you will be redirected to this Instruct platform. We leverage the Instruct platform for our workshops. So you just click Start, and it will start to spin up the basic infrastructure for you, like Kubernetes clusters. Pretty much simple as that. So, so I would just let it run this in the background for the infrastructure setup, and then let's get started with a bit of introductions. So. Solo was founded around 2017, and then we have now funded well-funded till Series C, and we have a lot of our customers keep growing, and we are playing in the applications networking space with Service Mesh, API Gateway, and as well as a Kubernetes CNI. So our products are based on the open source projects, so like Istio, Envoy Proxy, Kubernetes, and Cilium, GraphQL, and eBPF. So we have our team is spread across the world, and we have in APAC, I'm myself based out of Singapore. We have a team based out of India as well as in Australia and New Zealand. So we have a lot of our customers by industry. If you take a look at it here, in the financial service industry, telecommunications, or cloud native companies, those companies that are born in the cloud, or even in the technology companies like Chef Software. I used to work for Chef Software before. So this is just brief introductions about Solo, and I only have 50 minutes. Eventually, the workshop's going to take about 2 hours and 30 minutes. So I'm going to try to finish as much as I can. So, but let's see how it goes. So in terms of Istio, the workshops, we have this called Solo Academy. If you search here, Solo Academy, all of our workshops are available for free, and so that you can learn about Istio, you can learn about Cilium, GraphQL, eBPF, and all these things, and you can even take the certifications, and everything is free. From the Solo Academy. So in terms of open source version for the Istio, we have different types of 4 different workshops for the Istio. Today we're gonna start with the foundations, which is beginner, getting started, and then after that, if you complete, then you can even go to some advanced how do you operate, which is for day 2 Istio operations, and then you can go to the expert level workshops. It's free, as well as the Ambient workshop, which is we and Google worked together last year, 2022, and we open sourced the projects called Ambient Mesh, which is a Sidecar-less architecture, and also the workshop is available for free. Today we're going to focus on the foundations. So before we talk about the workshops, let me introduce a little bit about the why we do Istio first. So so now a lot of organizations are migrating their software architecture from monolith to the microservices, and then leveraging the cloud providers like AWS, Azure, Google, and then also running on the technologies like containers and Kubernetes, serverless, and VMs, right? So when we go to that distributed architecture, one of the most important things is become like this connectivity among these microservices become a central point of consideration and also the important design decisions. So how do these microservices communicate each other? How do these microservices, how do we do security? And how do we do observability? Let's say, example, you have a microservices running on GKE and you have a microservices running on AWS and Azure or OpenShift on-prem, right? How these microservices communicate to each other. What if the AWS, let's say one of the regions down and the underlying cloud provider, how are you gonna route the traffic from the AWS to your microservices? And what if the AWS come back and how do we reroute back to that AWS, your infrastructure, your microservices? So all of these, we call it application networking. So before we go there, in a distributed architecture, how do we normally develop, right? So application development team pick and choose their their programming language and also libraries to implement those, not only the business logic, but also the infrastructure logic. Like how do we do service discovery? Because these microservices need to find each other and communicate each other, right? And how do we do rate limiting? How do we do circuit breaking and timeout? And how do we do observability? So developers used to take their own respective programming languages, implement those logic together with the business logic. So, and then what happened is now with the microservices, each development teams pick and choose their own language. You gotta maintain all of these libraries. And what if this libraries got some issues and you need to patch and you need to redeploy your applications? It's gonna start to face your downtime. And then another thing is about observability perspective. So since the developers are using different programming languages and framework for their metrics, logging, monitoring, so the metrics that it comes out is different formats. So we don't have the unified way of observing all of your the microservices communication and latency and timeout and what's happening in the network. So these are the challenges that we start to face, and how do we solve that problem? So developers are best spend time writing code, focusing on the business logic, and let this infrastructure logic like circuit breaking, timeout, service discovery, and take it out from the abstracted from those business logic and abstract to another infrastructure layer. We call it, and then and then let those handle for you, right? So that increases the developer productivity and get more automations around that. So this is if you look at the left-hand side, take the business logic out, developer just focus on business logic, and all of these infrastructure concerns like connectivity, security, reliability, resiliency, observability to the proxy layer. We call it, we use in this case, we call an application proxy, like Envoy proxy here, and then we abstract it out. That would be the solution that move forward. And then, so those logic gonna be running alongside with your business logic, like your microservices, and then all of these application layer proxy will be configured by something called control plane, and then that's how then all of these form as a service mesh, and we call it service mesh. So, and then this is a more colorful diagram. So like introducing Istio. Istio is one of the open source implementation of the service mesh. There are a lot of other service mesh implementation out there like Linkerd and all this kind of thing. So now today we're going to talking about the Istio. So if you take a look at this diagram, so your microservices service A, B, and C will have, along with their own respective proxy. Here we use Envoy proxy as a data plane, and then all of these data plane, like Envoy proxy behavior and functionalities like circuit breaking, timeout, and telemetry, and all these things will be controlled and managed by this control plane called Istio. So this is an introduction about Istio. So Istio was created initially by folks at Lyft, Google, and IBM, but now it is a vibrant, open, and diverse community, and that includes individuals from like Solo.io, Red Hat, Intel, Ericsson, Salesforce, and many others company. And also, like according to the CNCF Cloud Native Computing Foundation survey, Istio is one of the most widely adopted service mesh in the industry. And now you can see the list of public reference customers can be found on the Istio website, including their related case studies as well. So while I was trying to explain to my colleagues and counterparts of the non-technical background and about and I came up with this, I tried to explain it clearly. So live before service mesh and then after service mesh. So if you take a look at it, all of these previous 5-10 minutes that I talk about in the one single slide. So before service mesh, then when we develop the microservice application, so which is one business logic, and then all of these like MTLS, like a security logic, service discovery logic, like traffic management, like rate limiting, timeout, circuit breaking, and all those like resiliency logic, and the logging, monitoring, tracing, all this logic, they use the respective libraries embedded into the code along with the business logic. So those now managed by developers, and then what happens is like when your microservices grow and start to scale, different programming language and framework, you're gonna maintain all these libraries. So, so that makes poor developer experience. So with service mesh, what we do is like we abstracted all of these logic, security, observability, traffic management, all of this logic from the business logic and offloaded into the Envoy proxy. Like we use in Istio, we use Envoy proxy, and that's how we handle. So oh yeah, sure. Thanks. Okay. So with that, developers now just focus on the business logic, which will differentiate your business values, and then all of these infrastructure logic will be handled by like platform engineering team, like service mesh. So that makes, what happens is that makes you don't need to manage all of these different programming languages and frameworks anymore. You will have one consistent like workflow, one consistent policy to across all of your microservices. So that is the life before service mesh and after service mesh. So hope like this makes it easier to understand. And now, since this is a workshop, then I'm gonna move to the hands-on workshop. So yeah, some of you like come in a little bit late. If you want to follow along, you can follow along with this link. 7 days of access to this lab, and then you can take the. You can also leverage our Solo Academy. All of your Istio workshops are free, and like we have 4 different types of workshop: beginner, intermediate, and as well as the expert level workshop. And by leveraging this academy.solo.io. So for this, in terms of if you take a look about the concept is just the control plane and the data plane. The data plane, we leverage the Envoy proxy, which is open source by Lyft, which is a ride-sharing company like something like Uber. So cloud native application layer proxy. So in this demo, what we have is I have like a Kubernetes cluster. If you take a look at here, we are leveraging this Instruct platform. I just run like K3s nodes on there. I think backend is running the GCP. So so far I have nothing at the moment. Default Kubernetes cluster. Just Kubernetes cluster. There is no microservices or no workload is running at the moment. So what we're gonna do is we're gonna first we're gonna be installing Istio. To install Istio, which is pretty simple, something like kubectl, we're gonna download Istio Ctl, which is to deal with the control plane, which is Istio-D, and I just downloaded the Istio Ctl, and then I just do some environment variables, and then if I do Istio Ctl version, so I have the Istio the Ctl, something like kubectl. This is to deal with the control plane. So before I install Istio, so I can explain a little bit about this Istio profile. So we're going to be leveraging Istio profile. So what it does is like Istio will have different profiles to get to make easy to get started. So let's say if you take a look at it, there are 3 components. One is the control plane, which is Istio D, and one is the Ingress gateway. Ingress gateway is where something like your to handle the north-south traffic. That means that the traffic will coming from the internet outside is going to hit your Istio Ingress gateway, and then it will hit your microservices. That is Ingress gateway for inbound, and Egress gateway is for the outbound traffic. So basically, it will be 3 components. So based on this profile that you choose, it will install these components. So in this lab exercise, we're going to be installing the demo profile. So the moment I install that it will be installing 3 components. So before that, there are a little bit of like sanity checks that you can do whether your cluster is fit and right to install the Istio. As I mentioned earlier about the profile, so if you take a look at it, like there are different types of profile, even documentation is a little bit behind. If you see there are more than like this profile that it mentions here. So now what we're going to do is we're going to be installing this demo profile. So when we install this, it's a Kubernetes native. So the moment we install Istio, we will find that there's a Kubernetes CRD. So it extends your Kubernetes functionality to work nicely work along with the Kubernetes. It will install a lot of Kubernetes CRDs related to Istio. So we can verify here kubectl get CRDs, and you will see there's a Istio CRDs installed. So if we really take a look at it, like I'm gonna explain here. So like if you are new to Istio, I just only want you to remember these 3 things for Istio. Istio provide basically 3 things. That's a summarize. One is around traffic management. One is around traffic management. One which is networking, application networking. One microservices talk to each other. Another one is around observability, because your Envoy proxy is going to be deploying alongside with your microservice, so it will generate a lot of telemetry, metric, and then also about security. How do we do zero trust, MTLS from one microservices talking to each other? So these 3 things that Istio provides. So based on that, if we take a look back to these CRDs, if you can look at here like there are a networking related CRD. Let's take example. Networking related CRD, and there are CRDs like security, and then observability if you take a look at like telemetry. So and then as I mentioned earlier, since we install Istio, it will install Istio related components in this Istio system namespace. So since we use the demo profile, it will install control plane, which is the Istio D, and then Ingress gateway, which is for to handle the north-south traffic, and then Egress gateway, which is handled outgoing, incoming and outgoing traffic. So which is similar to Kubernetes Ingress, but Istio provides more functionality. Yeah. Where even now, like Kubernetes will have the gateway API, which will leverage the Envoy proxy under the hood. So it's coming. Okay, cool. So pretty much Istio installation is complete. Now what we're going to do, the next step is Istio provide 3. One is traffic management, observability, and then security. So I'm going to install some of the add-ons related to this observability tools like Grafana, Prometheus, and Kiali, and all these. So Istio comes with some add-on here, but this is not really useful for the productions. Production we should like we should customize for whatever our requirements, whatever our business requirements is. So, but this is for the getting started. So I just use like sample. There's add-ons. When we download Istio, it comes with a bit of a lot of add-on features. So when I run add-ons, it will install Kiali, Prometheus, and Grafana. And then if we verify our installations, now we can see we have add-on features like Jaeger for tracing, Kiali, Prometheus, and Grafana. So pretty much that's a complete of the installation is completed. And then Istio have this Istio Cuddle tools. So Istio Cuddle dashboard, you can do the port forwarding here. And then you can access this the Prometheus UI. So when you play along your own, when you do this lab, it takes about 2 hours and 30 minutes to complete all of the exercises. Don't refresh your browser. If you refresh the browser, it will go back from the start. So just refresh here if this UI doesn't come up. So we embed it in the Instruct platform. Yep. So now here we have Prometheus. Now we have no data of the observability at the moment because we don't have any workload deploy at the moment. But you will have start to see some of the control plane data, like how your control plane Istio D is functioning, how your Ingress gateway is functioning on all these. So I'm gonna skip this like a dashboard, how you access the UI of these different tools, and you can follow along for like accessing Prometheus, Grafana, Jaeger, and Kiali by just doing the port forwarding using this Istio Cuddle dashboard command. Cool. So that will complete the first lab, which is installation. Pretty much that's it. So the next lab that we're going to be talking about is, if I remember correctly, is about the Ingress gateway. So we're going to be deploying. So we're going to be deploying some sample microservices, and then and we're going to be configuring our Ingress gateway to receive that like a north-south traffic. So since what we're going to do is we're going to be deploying sample microservices here, Istio in actions. The names come from our global fee CTO Christian Poster write a book about Istio in actions, and I think it's come from the name Istio in actions. It was the namespace. So we're going to be deploying 4 microservices in the Istio in action namespace. One is the web API, which is the front end, and it will call to the recommendation microservice, and it will call to the purchase history service. So we're going to be deploying that in our Istio in action namespace. So some of the people ask like how this microservices is created is if you take a look at here, samples web API.yaml, and is eventually one of the famous microservices you can test is called Nicholas Jackson wrote this fake service. So and we created leveraging that fake service to create this to create the fake microservices. So now if you take a look at now all of our microservices are up and running. Google get pods. So we have 4 microservices running right now. So if you take a look at it right now, 1/1, the microservice, that means you have 1 pod running 1 container, which is your business logic. Business logic is purchase history, web API, and the recommendations. So if you remember, like we had installed the Istio components under the Istio system. So if you focus here, like Istio Ingress gateway, which is now exposing as a load balancer, so that it can take the traffic from outside, and then we have the Ingress gateway. So what we're going to do is we're going to be playing with the Ingress gateway to handle the traffic coming from the outside. So what we're going to do is we just want to get this external IP of the load balancer. So we just do. I don't want to type again and again, so I just get the exported set as an environment variable. So this gateway IP, which is your Ingress gateway IP. So the traffic going to hit that Ingress gateway IP, and it will go to the microservices. So how it's gonna like, how's the traffic gonna go flow is like, we're gonna use car, which is representing as your mobile apps, mobile phone or external outside of your Kubernetes cluster, outside of your environment, from the internet, hit the Istio Ingress gateway, load balancer, and then it will go to your web API, and then recommendations, and then purchase history. That's gonna be the traffic flow. So at this stage, right now, as I mentioned earlier, we don't leverage Envoy proxy yet. That means one microservices is now running on its own. There's no sidecar injected at the moment. So what we're going to do is we need to configure this Ingress gateway behavior so that it's going to be it will be accepting the traffic. So if we think about it, if we take a look at it, like all these Ingress gateway and all these egress gateway, under the hood it's Envoy proxy. But Istio used the Envoy proxy and then extend it by writing what it is called. We call it a custom filter. Envoy proxy is written in C++, high performance, and extend that functionality. So Istio used extended version of the Envoy proxy. So what we're going to do is we're going to be configuring this Envoy proxy, this little Envoy proxy here. So we're going to be leveraging this Kubernetes CRD core gateway resource. If you remember earlier, so when we install Istio installed different CRD, Kubernetes CRD. So we're going to be leveraging this gateway CRD. So what it does is this gateway CRD, when we configure, we're going to be selecting this. We're going to be saying that we're going to select this Ingress gateway using the Kubernetes label selector, and then we say, okay, we're going to be listening on port 80. So if we take a look at it here, and then okay, we are expecting the host to get access from Istio in action or IO. So well, I mean, right now is port 80, but nobody do that. So we're going to be in the next lab, we're going to be doing listening on port only 443, which is we're going to be applying the certificate on the Ingress gateway to secure. So under the hood, like the moment we configure this gateway CRD, what it does is like Istio D take this gateway config, and then Istio D translate this config and push it to this Envoy proxy, Istio Ingress gateway, so the Envoy understand. So so that I mean the user like us, we don't need to deal with the Envoy proxy directly. Because let's say, think about it like if you have your microservices, hundreds of microservices, thousands of microservices, you may not want to configure all of these proxy individually, right? So that's where we're going to be leveraging the control plane. And also, since it is a declarative way, so it's easier to, well, I mean easier, it's YAML, better than JSON. So yeah, we're going to be leveraging this YAML, so that, and then this is a gateway. So now the most important concept here is that this gateway and virtual service concept. So the moment we configure the gateway resource, what it does is like this Istio Ingress gateway will listen. That's it. It doesn't know how to route to, should I route to web API, or should I route to recommendation, or should I route to some other microservice? It has no idea. So that's where the next Istio's resource comes in, is called virtual service. So I always explain about Istio gateway is great into listening, and Istio virtual service is for the routing. So what we're going to do is, let's see if we take a look at it here, the virtual service. So this virtual service and gateway is actually linked. So if we take a look at virtual service config, it say which gateway that should I link to. So here, if you look at this gateway, the name is Web API Gateway, and it's linked to this gateway, Web API Gateway, because there may be multiple gateways in your environment. For example, there are customers like you have 3 different gateways. One gateway is handling the partner. Let's say you're a bank, you partner with some of the banks or some of the payment organizations. That's only for the partner traffic. And you will have another gateway handling for compliance, for example, for audit, and you have another gateway handling this external traffic. So in that type of scenario, we need to, that's why we can configure which virtual service, which gateway is for which virtual service and which gateway resources is for which Ingress gateway. Hope that makes it a little bit more clear. So since we have that the gateway and virtual service, gateway is listening and virtual service is routing. So now what we're going to do is we're going to be deploying that to resource in the clusters. So if you see here, we have this virtual service and gateway is configured. So now this Ingress gateway knows what to do. It's listening on port 80 and it's going to be routing to here. It will route to your web API, not to the recommendation, because web API is our front end service. So now we can test. We're going to be using the call command testing to we call into the Istio in action.io, because in the gateway we configure that we're going to be listening on Istio in action.io. So we put the headers here, and then we call into the gateway IP, which is our load balancer. And now, if you take a look at the output here, it's called to the web API. From the web API, it's called to the recommendations microservice, and its recommendation calls to the purchase history. So now our application is able to access from the outside, but from using the port 80, which is not secure. So the next step, what we're going to do is we want to secure our inbound traffic. So just what we need to do is we just need to create a TLS certificate. So the way that we do is maybe you will be leveraging your own the PKI infrastructure or things like that. And then, but in here, what we're going to do is we're going to be just creating the root certificate and the certificate chain and all these, and creating that certificate as a Kubernetes secrets. So TLS here. So kubectl create, and then the secret TLS and Istio in action cert. So, and then what we need to do is we need to update our gateway configuration. So now, previously, our gateway is listening on port 80, and there is no certificate attached to it. Now, what we're going to do is we're going to be updating our gateway using, use the TLS certificate that we just created as a Kubernetes secrets, and then now don't listen on 80, listen on 443. So, and then I'm going to apply that. Gateway, new gateway config, and now I'm going to use I'm going to accessing the HTTPS now, and using certificate. This is for simulation, so I need to pass the -c cert. So now it's successful. Now, if I try to access using the port 80, it won't work anymore. But there may be a question like, can we do the redirections? Like, okay, 80 comes in, and can we redirect? Yes, we can do that. So those more details configuration going to be like Istio gateway config reference. If you go to here, there is there are a lot of parameters that you can see this like HTTPS redirect. So you can configure all these like by referencing the Istio docs. So I feel like I'm just running a marathon because we run this workshop for 2 hours and 30 minutes. Now I have to finish in 50 minutes. There's no way. Yeah. Okay, so far everyone's okay. Like the first step we do is just install the Istio. Now we have Ingress gateway running. So now your microservices are receiving the traffic. Now is the interesting part. Is we're going to be implementing that microservices with the Sidecar. We're going to be injecting the Sidecar right now. So now assume that developers, you just focus on the business logic, develop microservice, all of these infrastructure concern, or the service discovery, rate limiting, timeout, all this kind of thing. Don't do that anymore. Leverage Istio Envoy proxy. And then let's do that. So the way we do is we just need to label that Kubernetes namespace that your microservices is running, and then we just pass this command called Istio injection enable. So if you do that, if you verify your Kubernetes labels here, you can see Istio injection is enabled. So by doing that, it won't inject the sidecar because we deploy the microservices first, and then we label that, hey, Istio, enable the Istio, right? So what we need to do is we need to do the rollout restart for that microservices so that it will inject the sidecar. So now if you take a look at it, Istio in action namespace, even though we say that injection enabled, the microservices is still just 1/1. There's no sidecar injected at the moment. Yeah, so I'm gonna skip some of these information that, like, to enable sidecar, your applications, your microservices have some requirements needed, like your service name. The service name must be Kubernetes service have a name, and you need some of the your pod must not run as a user ID 1337. All these kind of like requirements to get the Istio sidecar injected. So all of these information in the Istio website, and make sure that you need to have your applications meet those requirements before you inject the sidecar. And then, like, there are some questions around, like, what if, like, the pods because of the security requirements, your pods doesn't have those rights, like net admin rights, and how we're gonna do? Like, you can use like Istio CNI, which is like Kubernetes CNI layer. You can do all these kind of solutions. So I'm gonna skip all these details and let's do the rollout restart. So what I'm gonna do is just do the kubectl rollout restart deployment, and then if you take a look at after rollout restart, this web API will get sidecar injected. So we will get 2/2. So I'm gonna just do the watch. So now it's the web API is now running 2/2 now. So now your microservices have the sidecar injected. So when this microservices from like now how the traffic flows becomes from the previous step. So previous step, the traffic comes from outside, hits your load balancer, hits your Istio Ingress gateway, which is the Envoy proxy, and now it hits Envoy proxy, not to your application directly anymore, and then your applications. So now the traffic flow now started to change. So if you take a look at like logs, making sure that your application is fine, everything is fine, and then now let's validate that we still can call that web API service. Everything is good. So under the hood, what it does is when we inject that sidecar, like what it runs is like there's a two containers run. One is the init container. So basically, what init container does is like init container use the proxy image, which is the Envoy proxy. As I mentioned earlier, Istio use the extended version of Envoy proxy, and then it will do traffic redirection using the IP tables under the hood. So, and then so the traffic comes in, it will go to it will direct to the Envoy proxy and then go to your microservices. So the question here is like, now you have one pod, two containers. One is your micro business logic running microservice. One is the Envoy. How do they communicate? It's loopback internally. So now I'm going to test running kubectl exec and then web API, just focusing on the Istio proxy, which is a container. And if I take, so this is if you want to know details about how this Istio sidecar proxy init sidecar works, how the Istio proxy works, as you can take a look at it from here. So for the sake of the time, I'm going to skip the details, and I'm going to do the same. Do the rollout restart for my 3 other microservices, like recommendation and purchase history. So right now, if we take a look at microservices, our microservices right now, we have, I'm going to watch, we have all of these sidecar started to inject. Did I restart? Yep. Any questions so far? So now the traffic, sorry? Oh yeah, sorry. Thanks. Yeah, I'm excited. And okay, cool. So now we have Sidecar injected from all of our microservices. So now the traffic flows started to change. So now Web API not talking to the purchase history or recommendation directly. So it will go through the proxy, something like this right now. So this will become the behavior. So Sidecar, by your microservices, talking to another microservices, it will go to the Envoy proxy, Sidecar. So now everything's still works. So what do we gain? Since the traffic is going through the Sidecar proxy, talking to another Sidecar proxy, so all these Sidecar proxy generate a lot of telemetry metric. So now you can start to have like a data about how this traffic going, how's the logging, how's the monitoring, all of these started to gain. And also, not only that, you can start to do the zero trust security. That means this Sidecar proxy represent your workload identity. So it will get a certificate issued by this Istio control plane, get the certificate, and then this microservices now talk to another microservices. It will go to the Envoy proxy. They do this MTLS, not going through directly. So that's the difference between, let's say, if you're running on Kubernetes today without service mesh running on the Sidecar, all of these Kubernetes by default they communicate each other by default. If you think about it, Kubernetes itself runs like a traditional castle and moat architecture. Let's say, example, your Ingress will be the secure with the TLS, but the moment you pass that Ingress, once you come inside, is plain. Of course, you may be leveraging the Kubernetes network policy and things like that, but like by default, it is traditional castle and moat architecture, like how we did in the traditional data center networking days. So with this Istio, you're going to be implementing the zero trust. All of these will be your workload identity. So how Istio leverage this workload identity is this called SPIFFE, Secure Identity Framework for Everyone. And if you take a look at all of this individual Sidecar proxy, and you will get that every Sidecar proxy will have the ID, which is called SPIFFE ID. It leveraging basically service account for your of your microservice. Cool. So since we have that Sidecar proxy running alongside with your microservice, and now we can start to do the MTLS. By default, Istio have two security, two peer authentication mode. We call it peer authentication. One is a permissive mode and one is a strict mode. So permissive mode is like make it easier to onboard your microservices to the MTLS. So permissive mode allow plain text as well as the MTLS. So that means like you have your microservices running without Sidecar in another namespace, and you have the microservices with the Envoy proxy running on the another namespace. With the permissive mode, they still can communicate. And then if we force it, and then after that, we will be looking at all of your telemetry, all of the data, everything is fine. And then we're going to be enforcing that microservices use the MTLS, and then we apply that. We just apply that security policy as a strict mode, and everything must communicate through the MTLS. If not, it won't work. So, which is about this MTLS. So, one of the reasons that most organizations adopt Istio is about this security MTLS zero trust features. So let's say here, if you take a look at it again, we just leverage this Istio CRD, peer authentications. The mode is strict, so only two modes, strict and permissive. And if we configure right, if we take a look at right now, by default is permissive, so that microservices can talk to each other without MTLS and plain text. So now I deploy another microservices in another namespace and test, it works. Because now another microservice is running in another namespace, there's no sidecar injected, so there's no secure identity, but it still can talk to the microservices with the sidecar. So with the interest of time, I think I'm going to end this lab here. So if you have any questions, I can answer. If not, I can talk a little bit about what Solo does and what we do. So according to the CNCF survey, I know the service mesh is pretty new to the industry and also adopt. One of the challenges that adopting a service mesh is around the shortage of engineering expertise and understanding of the benefits of service mesh. So that's why we created one of our core activity is Solo Academy. So we created and invest a lot of time on the educating in the industry. And also, if we take a look at our technical leadership, so Solo is basically enterprise of the Istio. So we have, in the Istio project, we have 5 technical steering committee seats, and now 3 are from the Solo that will drive the direction of the Istio project. And also we have the dedicated, the open source team contributing to the upstream. So our contribution to the Istio is we don't fork from the open source project, we contributed directly to the Istio. So that is our technical leadership around the Istio open source service mesh. And then what is the difference with open source Istio and then with our, we call it glue mesh, is around, with the Istio, it's like a Kubernetes, like every quarter is releasing a new version. So you have your Kubernetes version, keep upgrading, and then you have the Istio version need to keep updating, patching. So what we do is we support like N-4. So that means you have 15 months of runway to upgrade, patch, and for your organizations. And we have 24/7 support. And also, as you see earlier, we have dedicated team of team focusing on the Istio. So when you think about Istio, think about Solo. And then on top of that, when you started to scale, now organizations started to go multi-cloud. So you will have the cluster running on different cloud providers, even on-prem, for whatever reason, for legacy requirements. How are you going to communicate across all these different clusters? This is where it's coming. So that's where, in the right-hand side, is global service discovery. So you have your microservices on GK Google, and how do you talk to microservices running on your AWS? So global service discovery, and how do we do the advanced failover routing? We, like 2 months ago, the Azure down, and then your Kubernetes clusters is impacted if you're running on the Azure only. How are you going to reroute the traffic to the another cloud provider on another cluster? What if it comes back and it is nearer to go to the AWS because of the latency requirements? And how do we automatically reroute back to that, which is called locality-based routing? So all of these advanced routing, load balancing functionality, we provide on top of that. We enhance open source and write custom filters, custom CRD to provide it, to make it easy to consume and adopt Istio at scale. And on top of that, we have like global observability, because you will have one Kubernetes cluster running on the AWS. You have your metrics, but what about you have multiple cluster? How do you do observability for all of your cluster across the cloud from the single unified control plane? That's where we come in. We created this called management controller, management plane, which is I call it like we created Istio for Istio to manage all of your Istio across the Kubernetes cluster from one single place. And then for the security reasons, we have the FIPS, FedRAMP requirements. All these are met for our public sector customers and the government organizations. That is where on the security and compliance side. So that is the differentiated value with open source version and the glue mesh and the enterprise version. So if any one of you are network engineers here, so if you're familiar with OSI 7 layers, because I came from the network traditional network engineering background, like the Cisco, VMware, all these kind of days. So I find it easier to talk to the network engineers. What is the Istio? So if you look at here with OSI 7 layers, and that's where the Istio comes in, and this is where the glue platform. So starting from layer 3, 4, all the way to the layer 7. If you take a look at here, called layer 8, our CEO added as a layer 8, which is a GraphQL. So like REST versus GraphQL. Now organizations started to adopt GraphQL. So we have that glue platform as a GraphQL module as well. So a little bit, if you want to know a little bit about that, how we are innovating with the GraphQL and the versus, like you may be familiar with Apollo and stuff, and please join to our booth, and I can talk more details about our product portfolio. So I'm not sure I stick up time or yeah. So basically we have 3 different products from the Glue network, which is on the layer 3, which is Kubernetes CNI, because you need the Kubernetes CNI. And then after that, Glue Mesh, which is for your service-to-service communication for Glue Mesh. And another one is Glue Gateway, which is your API gateway. So instead of adopting the API gateway, the one vendor, you have like a service mesh for one vendor, you have one service mesh for another product. So you're going to manage 3 different API. So if you adopt the Glue platform, you have a single unified management API, and then you can manage easily. And then if you have any issue, just call Solo. We will help you support everything from all the way to CNI to all the way to the API gateway. So that's why we call it application networking. So if you have any questions that I can answer. Yeah, so yeah, that's a great question. So alongside with, since it's a sidecar, every microservices needs sidecar. So that is the money. Right? That sidecar costs money for the moment your microservices grow, the sidecar grow. Right? So that's why we partnered with Google, and we created this called sidecarless architecture, sidecarless approach. We call it Ambient mesh. That means instead of running every sidecar per workload, we have one sidecar per node. So that will reduce your costs. And that is called sidecarless architecture. So that's what we call it ambient mesh. Yeah. So we have, industry, we talk about, it's not the either or. It depends on the requirements that you're going to have. Like you may be adopting, some of the applications need layer 7 functionalities. They will be adopting the sidecar approach. And some of the applications, they can adopt the sidecarless approach. And we believe that sidecarless will be the future for service mesh. Yeah. So yeah, so it's about the cost as well as the latency. So if you think about it, like from one microservices to B, so it will have 1 hop, 2 hop, 3 hop, right? So with the sidecarless, you still have all of these like a functionality, like the provided by Envoy, but instead of running a per workload, per microservice, it will per node. So yeah. Yeah, so with that, we leverage this called the Z tunnel, called Zero Trust Tunnel. So I can talk more details on my booth. So like that, it will provide the same MTLS security layer 7 functionality. So we call it the Zero Trust Tunnel. So from the moment you run the sidecarless architecture, the moment you run like okay, you need that you need the layer 7 traffic from this microservice to this microservice, and it will create we call it Z tunnel, and then the traffic gonna go through that yeah. Okay, so I think the time is up. So yeah, thanks so much for the questions. If you are interested about this, how the ambient mesh sidecarless architecture work, welcome to our booth. We have the booth there. Thank you so much for joining. Thank you.